Yes, sir. Good afternoon, sir.
Okay. So now let us start your another topic, uh, mobile communication. Uh, in this topic, we will discuss uh, what is communication, what is data communication, what are the different component is associated with the data communication, and what is mobile communication, uh, uh, and what is the different type of mobile communications and their architectures. So first, what is communication? Here, that is, when we are sending a data from one device to another device, it is known as communication. When you send your data, when you talk with your phone with your friends, it is also a communication. In past days, uh, a letter was sent. There is no other communication. The letter was sent. You have to post the letter in your nearest post office, and that letter is carried out by the post office serviceman to your destination, and your address is written on the envelopes. Then it is delivered to the destination. That is also one type. That is also one type of communication. So when we are sending data from one device to another device, the data may be any type. It is called data communication. The major component of the data communications are, there are five major components. We will discuss one by one. There are five different major components in data communication. That is, absent of one, absent of one will stop the communication. That is, you cannot communicate. That is, it is not possible to communicate data. First is the sender machine, the sender. That is, who has data and you want to send. That is, you have a sender machine. It may be your computer, maybe your laptop, maybe your phone, whatever may be. That is the sender machine. There must be there, which contain data and want to send that. Similarly, in other side, in the destination side, there is also another system, another device, which want to receive data. The destination computer, the destination devices. Number two. Number three, the data itself. The data may be text file, may be an image file, may be a PDF file, may be voice, or may be any graphical any graphical data. So data may be any type. So there are third component is data itself. The fourth one is medium. The first is medium. That is, when you communicate with two devices, these two devices must be joined in a uh, medium. The medium may be your wire medium or wireless medium. There may a cable, maybe the cable is attached within two devices, maybe any other wireless communication, satellite communications, Bluetooth communications. So there are different type of medium are there. Fourth one, the fifth one. First is sender, second is receiver, third is data, fourth is the medium. The fifth one and the important, which actually plays a vital role, is known as protocol. Is known as protocol, which is not seen, but it is protocol is there. Uh, the protocols is nothing but it is a rules and regulations. There are some rules and regulations. The source devices, the destination device must follow that. That is, the protocol defines in which manner data will be sent and in which manner data will be received. Take a small example. Suppose source devices send a data in a higher rate, in higher rate. That is, suppose the sender device is a new one. It has the latest technology, more RAM, more processor, more speed processor. So it send data more rapidly. But on other hand, in the destination side, suppose the devices are poor configurations. Okay, the processor is poor, processor is not latest, old one, and the data which will send very rapidly from the source sites, it cannot be received the same rate in the destination sites. So there should be a problem because the rate from the source side is high and more, and the receiver sides receive it in a low speed. So there should be a mismatch. Protocol manage it. Protocol manage it. First example, this is a work of protocol has many works, many functions. This is one of them. You take example of second one. Suppose during data communication, the data suffers some error. Data is suppose affected by some error. Some bit is missing. And you know that data is traveling in a digital form 0, 1, 1, 0. Suppose one is missing and one is converted 0 to 1, 1 and 0 due to any reason. In a, you know that during the way this data may be affected by um, some external parameters like any strong electric field, magnetic field. The data 0, 1 may be altered or missed. So data may contain some error. So this is also detected by or corrected by the protocol. Okay. So there are the function of protocol are more we'll discuss, but this is also protocol. So my aim is to say that during the communication, the 5 components are essential. Absent of one, it is not possible for data communication. Sender, receiver, data, communication device or the medium, and the fifth one is protocol. So 5 major component of a data communication. So here the mobile communication. As the name suggests, mobile communication, the medium is not wired. The medium is wireless. Where the medium is wireless, that is called the mobile communications. We are using our mobile phone. Our mobile phone is the best example of your mobile communication because we don't have a physical wire to connect the mobile phone with another mobile phone to data communication. So our mobile phone, our smartphone is the example of the best mobile phone. Sorry, the mobile communication device. You see, the mobile communication is the use of technology that allow us to communicate with other different location without the use of any physical connection. No physical cable is used. No wire is used. So mobile communication makes our life easier and it saves time and effort. Let us see how the mobile communication save our time and effort. So a mobile phone, as we discussed, is called a mobile cellular network or cell phone or hand phone is an best example of mobile communications or wireless communication. What are the features? First is high capacity load balancing. That is, we know that uh, while data are communicated through source to destination, uh, there is not a unique path. There is not a unique path. There is a various path from source to destination. Generally, suppose when we are moving from one source to destination. Suppose you are moving from home to your nearest office or nearest your school, college. So there may be different ways. That is, I want to say that the path you are traveling from your home to your office or to your college may not be unique. There are different paths are there. You can pass, you can travel in any path according to your convenient. That you suppose always you select the shortest path. Uh, so I mean to say that you have different ways or different path from traveling from the source and destination. There may not be a unique path. Here also, when data is communicated from one to another, suppose one path is contains some traffic, that is it high loaded. So this is this capacity load balancing. High capacity load balancing means when access point is overloaded, one point is overloaded, the system will actively shift user from one access point to another point. Suppose another the other users are using that access point, they are shifted to other user point automatically. So depending upon capacity which is available. Okay, so if the other access point are available, so the user are shifted to the other access point, so that the data pass through, that data passes to easily, and there is no overloaded, no traffic jam. Scalability, the growth of the popularity of the new wireless device continuously increasing day by day. If you go back to 10 to 15 years, 10 to 15 years, so the users in mobile communication was very less. Nowadays, the growth of the mobile communication or wireless devices increasing day by day. The wireless network have the ability to start a small if necessary, but expand in terms of coverage and capacity as needed. So the uh, wireless network need not to, if you have wireless network are there and the number of user increases, it need not to install a new one. So it has a capacity to expand in terms of coverage and capacity as needed without having to overhaul or build an entire new work. Okay, so new network without entering a new entirely new network, it can be expanded in terms of coverage and capacity. So this feature is known as scalability. So we need not to suppose there is a more user are there. The capacity is 2000. Suppose you see here, first is 1000 users, then increase at 2000, then 3000, then 4000. So user increases. So we need not to construct a new one network by ignoring the first one. So we have to expand it in terms of coverage and capacity if needed. uh, Network management system. Nowadays, wireless network are much more complex and may consist of hundreds, even thousands of access points, firewalls, switches. These are the electronic devices, manage power and various other components. So the network management systems manages all these things. Access point are there, all the other access point there. The some user belongs to some access points. The wireless network have a smarter way of managing the entire network from a centralized point. So from a centralized point, it can be managed or controlled by the wireless network have a smarter way. That is, you can manage or control the entire network by sitting one centralized point. So indoor and as well as outdoor coverage option, it is important that our wireless network has the capability to adding indoor coverage as well as outdoor coverage. It is obvious network access control. Network access control can also be called as mobile device registration. It is essential to have a secure registration. So every user have to register it, have a user ID or password or a unique ID. So network access control the role of the user and enforces policies. So there are some policies, there are some rule and regulations. So NSC can allow the user to register themselves to the network. It is helpful feature that is enhancing the user experience. So every users have to register. That is the server has the all the information about the users, about the other nodes which are attached to a particular network. The main important thing is roaming. That is when we are roaming from one point to another point. You know that in between the way, suppose you are moving in a moving car, suppose you are moving in a train. So during your travel, that is the access point are changed. Uh, that is you are moving from one access point to another access point, another access point, then another access point, but your connection is not dropped. The connection is not disconnected. So it is allow this feature is called the roaming, which allow us the user successfully move from one access point to another without ever noticing a dip in performance. There no drop in performance. Their connection is not dropped. Connection is not disconnected. If you traveling, you can that is you can continue your communications. There is no disturbance without any disturbance or without any drop in your communication. So allowing a student to check their mails as they walk from one class to other. Switching. A network switch is the traffic cop of the wireless network. Switching is the essential part of the every fast, secure wireless network for several reasons. It helps the traffic on the network flow from more efficient. As I told, uh, that is there is various ways from the source to destination. That is, data can communicate from source to destination in different route. And we have also sometimes when we're traveling from our source to source point to destination point, we have also different route, but we always select a shortest route, which is the shortest in the term of distance, the shortest in the term of price, whatever may be, but we always prefer the shortest route. Okay. Similarly, uh, the switching. The switching also select the fast the route, that is which are the fastest secure wireless network for several reasons. It helps the traffic on a network flow from more efficiently. As I told that is it also detect the flow of your data, that is it will manage the traffic. If the one route if there is a traffic, it may be redirect the data in other route. It minimize unnecessary traffic. It creates a better user experience by ensuring the traffic is going to be right places. This is the mobile communications. That is, we may continue the communications using any devices, mobile devices, which does not have any wired connection or cable connection. So, what are the advantages? Flexibility. Well, communication enable the people to communicate with each other regardless of the location. So the location does not plays any role. You can communicate from any location, from your office, from any telephone booth. So there no need to be you must be in an office while communicating. You must be in telephone booth while communicating, or you must be any particular place while communicating. So regardless of any place, you can communicate. That is, this feature is known as the flexibility. Obviously, it is cost effectiveness because in wireless communication, there is no need of any physical infrastructure. There is no need of the physical cable, physical wire. So the wires cable are not used, or the maintain also, if they are wire and cable, they are associated with the maintenance cost. So hence the cost is reduced, and the wireless communications is considered as a cost effectiveness network. Speed improvement can also be seen in speed. The network connectivity or the accessibility was much improved in accuracy and speed. So you will also get the high speed in case of mobile communication. Accessibility. With the help of the wireless technology, easy accessibility to the remote area is possible. In a rural area, online education is not now possible. Educator or students no longer need to travel to far flung area or to teach their lessons. So nowadays, the people in the rural area also they have accessibility. They have communication with the mobile communications. So they are using uh, the mobile phones now. Okay. So these are the advantages. So what are the threats? Threats we will discuss. Actually, the main threats is security. The main threats is security. We'll discuss about that. So let's discuss some methods of multiplexings. So as you know, using or giving service to more than one user in a single bandwidth with a wire or wireless medium is known as multiplex. Okay, that is the medium is single, but they are used by various users. So the access method are multiplexing technique that provide communication service to multiple users in a single bandwidth wire and wireless medium. It is called multiplexings. Communication channel, whether they are wireless spectrum segment or cable connections, are expensive. So wireless spectrum or cable are expensive. So communication service provider must engage multiple paid user over limited resources, make a profit. So access method allow many users to share these limited channel to provide the economic of scale necessary for a successful communication business. So that is why the multiplexing is required, which allow multiple user to use a single bandwidth wire or wireless communication. The first one is your FDMA, frequency division. So frequency division multiple access (FDMA) is a process of dividing one channel or bandwidth into multiple individual bands. So that is why it is called known as FDMA. That is a single bandwidth divided into multiple individual bands, and each user is for use by a single user. So is divided by single band, and each user uses a single band. Each individual band or channel is wide enough to accommodate the signal spectra of the transmission to be propagated. So here that the bandwidth is divided into smaller bands. The entire bandwidth. The data to be transmitted is modulated on the each of the subscriber, and all of them are linearly mixed together in the again on the next sides. That is the destination side. The best example is the your cable television systems. The cable television systems, you will get the different channels are coming in a one single cable. The medium is a single coaxial cable that is used to broadcast hundred of channels in video audio programming to homes. So the cable television systems is an example of FDMA. It contains on a single cable, but you will get more hundred of channels which is connected to a local television in your home. The coaxial cable has useful bandwidth from about 4 megahertz to 1 gigahertz. This bandwidth divided up to 6 megahertz wide channel. So this is a simple TDMA, time division. TDMA is a digital technique that divides signal into band into time slots. Each time slot is used to transmit one byte or another digital segment of each signal in sequential series data format, as the name suggests, TDMA. So here it is not divided by the basis of frequency or bandwidth, it is divided into time slots. So this technique works well with slow voice data signal, but it is also useful for compressed video and other high speed data. The example is use a T1 transmission system which has been used for year in the telecom industry. So it is a T1 connection. It used in basically in telecom industry. It is a good example of time division multiple access TDMA. T1 lines carry up to 24 individual voice telephone calls on a single line. So T1 lines, it is one of the medium used in telephone industry, and this carries up to 24 individual voice telephone calls. So one cable, one T1 lines consist of 24 individual voice telephone calls on a single line. The GSM network, the GSM global communication system, cellular phone system is TMA. Nowadays, the GSM is not used, is very rarely used. So the GSM, global system of mobile communication, also use the TDMA base. Its cellular phone system is TDMA base. It divides up to radio spectrum up to 200 gigahertz bands and then use time division techniques to put 8 voice calls into one channel. And it is a CDMA. It is also a multiplexing uh, method. CDMA is another pure digital technique. It is also known as spread spectrum because it takes the digital version of analog signal and spread out it over a wider bandwidth at the lower power level. So this method is called direct sequence spread spectrum, DSSS as well. After your GSM, the 3D cell phone technology called wideband CDMA or WCDMA, wireless CDMA, use a similar method to compress voice 3.84 megabits per second, shipping course is 5 megahertz channel to allow multiple users to share the same band. So CDM is another multiplexing technique. So this is the summary of FDMA, TDMA, and CDMA. So you see the first one is the frequency division multiple access, time division multiple access, and code division multiple access. The first one is sharing the bandwidth. The second bandwidth with the different station takes place. The bandwidth is share, the bandwidth is divide. The second one, the sharing of time of satellite transponder takes place. The time there are different time slots. And code division में that is there is both. In this there is sharing of both bandwidth and time among different station takes place. Code word is necessary in the CDMA. There is only need of the guard bands. Guard bands means that is the uh, gap between any two bytes of the data is filled by some bits. It is called the guard bits between the adjacent channel are necessary. In this guard time of the adjacent slots are necessary. So in CDMA, both guard bands and guard times are necessary. In FDMA, synchronization is not required, but in TDMA, synchronization required because the time slots that must be synchronized in the destination side. And the data rate is low in FDMA, medium in TDMA, and very high in CDMA. Mode of data transfer is continuous, it is bursts, and the last one is digital signal. Mode of data transfer is digital signals, and it is highly flexible. CDMA is highly flexible, TDMA is moderate flexibles, and DMA little flexible. Here is the comparison and of FDMA, TDMA, and CDMA different multiplexing technique. GSM mobile communication. GSM communication, that is a global system for mobile communication. We have already discussed what GSM, which FDMA use GSM. Let us see what is GSM and what is the architecture of GSM. Uh, mm, Initially, the GSM mobile communication was used. Nowadays, it is very rarely used due to its speed. GSM stands for Global System for Mobile Communication. It is an open and digital cellular technology used for mobile communication. It uses four different frequency bands, 850, 900, this frequency band are there. And it is the combination of FDMA and TDMA. Both technologies are used in GSM. Supports internal roaming. These are the first feature. The roaming, they are available in this network. If you travel from one place to another place, or from your country to another country, the roaming feature are there. You should not drop your communication. If you there is a agreement between our communication, our country's communication and the others. So there should be roaming facilities there in GSM communication. Clear voice clarity, ability to support multiple handheld devices, spectral frequency efficiency, low powered handheld devices, that is the mobile device which use GSM network has low powered. It does not consume more power. Ease of accessing network. This network is access international ISDN capability. The architecture is important. The GSM, how the GSM constructed, what are the architecture of GSM? The GSM network can be broadly divided into four parts. You see, the four parts are there: the mobile station, MS, base station subsystem, BSS, the network switching subsystem, NSS, the operation subsystem, support subsystem, OSS. So GSM mobile communication divided into four different parts, components. We'll discuss one by one. The mobile system, mobile station, the base station subsystem, the network switching subsystem, and the operating support subsystem. First, the mobile station MS. As we discussed in the previous slide, it consists of four major component. The first was the mobile station. The MS consists of the physical equipment such as the radio transceiver, display, and digital signal processor and SIM card. That is where the mobile, that is the physical equipment. It may contain a display, because suppose you take the example, your mobile phone, it must have a display, a SIM card, a DSP processor, digital signal processors, and a radio transceiver. So it is mobile station. It provides the air interface to the user in GSM network. As such, other services are also provided, which include voice teleservices, data barrier services, the feature supplement services. So the mobile station contains this part, the first equipment of the mobile station. So the SIM, we have a SIM card in our mobile phones. It contains some, you have to register with the mobile your service provider. The SIM provide personal mobility. It recognize you. It is a personal mobility, so that the user can have access to all subscribed services, irrespective of both the location of the terminal and the use of the specific terminal. So you have a SIM card. You have to insert that card into your cellular devices to receive the call at that phone, makes call from that phone, or receive other subscribed services. So if you take a SIM card from any mobile service provider, you use and access all its services. So you have to insert that card to your devices. There is a, that there is a slot for that, in order to receive or make calls or accessing the data. So you have to need a, this is the minimum requirement for this communication. So besides the MS, the second one is the base station subsystem, BSS. BSS. The BSS is composed of two parts: base transceiver station and base station controller. The BTS and BSC, communicate across the specified base interface, enabling operation between components that are made by different suppliers. The So it consists of two parts, one is BTS and another BSC. The radio component of a BSS may consist of 4 or 7 or 9 cells. A BSS may have one or more base station, and BSS uses the base interface between the BTS and the BSC, the dedicated interface between the BTS and the BSC. So you see, BSS. So there is a connection. One is BSC, another is BTS. You see here, base transceiver station, BTS. The BTS houses the radio transceivers that defines a cell and handles the radio links protocol with the MS. You see, your MS may be your handphone, maybe your laptop, maybe in a large urban area, the large number of BTS may be deployed, because due to the traffic, if the number of users are more, so large number of BTS may be deployed. You see, this is the block diagram of a BTS. So sends the all it self and handle the radio link protocol with the mobile station. So write your registration number and name so that I'll give the attendance.
Uh, yes, enrollment number and the name.
Okay. So as we discussed the BTS, uh, um, each BTS serve as a single cell. It has the following function: encoding and encrypting, encoding and encrypt. That is, you know that the data while traveling needs encrypting, need to convert from uh, one form to another due to security reason, and it also needs multiplexing, modulating and feeding the RF signals to the antenna. So these are done by the BTS. Transcoding and rate adaptation, in which rate it should be travel. Time and frequency synchronized, how the time and data is synchronized in the other sides. Suppose for example, suppose data is divided in source side and due to easy communication or easy transmission. So when we reach at the destination side, it must be combined in the same order or same manner as original. This also done by the your BTS service. Voice through full or half rate services, decoding, encoding also. If data is encoding, there should be decoding in the other sides. If data is encrypted in the one side, source side, it must be decrypted in the other sides or destination sides. And equalizing receive signal, random access detection, timing advances, uplink channel measurement. So all are these function of the BTS serve in GSM network. So it plays a vital role. Then the next after MSS and BSS, it contains BTS and BSC. So your BSS contain two parts. One is BTS, another is BSC. So later discuss what is BSC. As the name suggests, BSC, Basic Station Controller. It manages the radio source for one or more BTS. It handle radio channel setup, frequency hopping, and what is the what is the it control the BTS. The BSC connection between the mobile. The BSC is the connection between the mobile and the MSC. MSC will discuss about the next slides. The BSC also translate up to 13 kbps voice channel use of the radio link to the standard 64 kbps channel used by the public switch telephone network PSDN. So the BSC is manages the control, as the name suggests, it control the BTS functions. It assigns and releases frequency and time slot for the MS. It assigns the frequency or bandwidth to the and also release or time slot for the MS. The BSC also handle intercell, so it is the frequency assignment and release also done by this part. It controls the power transmission of the BS and MS in its area. So it also control the power transmission, how the BSS MSS handle the power transmission. The function of BSC is to allocate the necessary time slot between the BTS and MSC. It is a switching devices that handle the radio resources. So it allocate the necessary time slots, how much time will be used by the BTS and next MSC, because you know that BTS send the data to MSC. As we discussed at a time, MSC, that is mobile switching center, because the BTS sends the data and transmit the data to the MSC. So now the data is in MSC. That is the with the network switching subsystem NSSS. The next part of the GSM. You recall the architecture, slides. It is here. So the third one is network switching subsystem. We have already discussed the MS. We have already discussed BSS, which contains two parts, BTS and BSC. Now the third one, the network switching subsystem and the operation support subsystem. Now to discuss NSS. So it is a important part of the networking subsystem, the main part of the mobile communication, where the mobile switching center MSC perform the switching the call between the mobiles and other fixed or mobile network user, as well as the management of the mobile service such as authentication. That is, suppose you are traveling, so the MSC plays a vital role so that your connection will not be dropped. You continue your communications. So it proposes a switching of calls between the mobiles and other mobiles network. Suppose you are when you are traveling, so you may travel from a network to another network. This may be a homogeneous network or may be any heterogeneous network. So while you are traveling, suppose you are traveling in a train, you may passes to various network. You may passes to one network and enter another network. So there will be a switch between the communication between one network to another network. So this switching is done by the your MSC or NSS. And the last one, the operation support subsystem. As the name suggests, it is support subsystem. It supports the communication. Let us see what are those support. The operation and maintenance center OMC is connected to all equipment in the switching systems and the BSC. So the OMC is the part of OSS. The implementation of OMC is called the operation and support system OSS. The implementation of OMC, the operation and maintenance center, called the operation and support subsystem OSSS. What are these functions? You see, first is administration and commercial operation. That is a particular user. Have a subscription here. Subscription, end terminal, charging, and statistics. How much data you are sending. The billing subsystem. What is the billing of a particular GSM mobiles? All chargings on end terminal, subscription, all are done by the administrator, and only commercial operation is done by the first function of the OSSS. Security management. That is when you are sending data, when you are uh, communicating, your data should not be lost. Your data should not be hacked by any other network or other persons. Security management, network configuration, operation, and performance management are also another work of the OSS. And maintenance tax. Suppose in one part, then user number increases, your signal become weakened. So there should be some maintenance system to recover your data again. So the maintenance tax also the part of the function of OSS. You see, here are the OMC, which has overall control of the entire GSM. You see, in BTS is there, MS is there, BS is there, BTS is there. You see, there is a mobile phone MS which connected to BTS, then BSC, and BSC is controlled by OMC. And all the MSc, BSc, or all are the controlled by the OMC. That is in support system NSS. Following is the figure which shows how OMC system covers all the GSM. So this is the GSM network. This is the different part of network, and this is the architecture of GSM. But GSM suffer a demerits. It is not used nowadays due to its low speed. So as the technology grows, uh, the GPRS systems, General Packet Radio Service, GPRS is a mobile. It is also a mobile communication standard that operate on 2G and 3G cellular network, 2G phones and 3G phones, cellular phone network to enable moderately high-speed data transfer using packet-based technology. So as the name suggests, General Packet Radio Services. So it is a packet-based service. We know that there are circuit-based and packet-based. So this is the packet-based technologies, and the GSM mobile communication we are discussing in the previous topic or previous slides uh, uh, is not used or rarely used due to its low speed. So to maintain the high speed as compared to GSM, GPRS mobile communications came to in the market, and it uses two generation and the second and third generation cellular networks. The mobile phones used in that one is called 2G phone and 3G. Nowadays, you know that is 5G. So at that time, there are 2G and 3G cellular phones are used, and the speed was 2G and 3G. So this is a block diagram. Mobile phone as a GPS modem. You see here GPS network. So when you are communicating from one device to another device, you see you can communicate with the nearest GPS network. This is there is a base station and GPS gateway which are connected to the internet. The other network also connected to the internet. So when we are sending data to another your destination, so data are moving from your nearest GPS network. Then the data is forwarded to nearest another network. And if your destination contain at that network are your GPS network, so it is easy to deliver. Otherwise, there is a GPS gateway which connect to the internet, and the other network are you know that all are connected to the internet, so you can that data can be communicated. So any devices, it may be a mobile phones, maybe a micro browser, maybe a modem are connected to the GPS network. Let us see how the GPS works. How does the GPS network work? General Packet Radio Service (GPRS) is essentially a packet switching technology that allow information to be transmitted via mobile network. It's a packet switches. Basically, a packet is nothing but it is a where if data size is more, it is divided into smaller parts, is known as packet. And the size of the packet is not fixed; it depends upon the uh, protocol used there. So it is a packet-based packet switching network. That is, the data are transmitted through in form of packets. So if you are sending the data is part divided into smaller parts, and each part is known as a packet. And each packet, you know that each packet is attached to this other some that is some header is added, some footer is added. It associated with the destination address. So there are various technology when data communicating. So in packet, this is called the packet switching technology. This is utilized for internet connectivity, multimedia messaging service, and other type of data transmission. GPRS is supported by GPRS cell phones as well as laptops and handheld devices equipped with GPRS modems. So all the devices which are equipped with GPS modems use this network for data communications. Subscribers have reported downstream bandwidth up to 8 kbps only at that time. So now, if you consider nowadays, it is too small. If you compare the two networks, now we have already discussed two type of network. One is GSM and a GPRS. You compare to the original GSM system, GPS technology provides various perks and advantages to the user and network provider. Let us see what are the advantages. Companies commonly use this to create precise data capability using mobile communication technology. Uh, some benefit of GPRS are, you see, obviously speed increases, billing made simple. There are some billing issue in GPRS in GSM system. So here billing made simple. That is, a subscriber will get more information about its billing, how much data will send, what is the cost of it, data transmission or using that is the services. Increase speed. Obviously, the speed is increases. So GSM suffers a low speed and always on connectivity. That is there's no time bound. That is, it will works in 10 hours. After that, it will take some rest or disconnected. No, it 24 hours work. So it is known as connectivity. Always on connectivity. So the first advantages was billing made simple when compared to the circuit switches services. We know that it is packet switches services. It is not circuit switches. So GPS packet transfer offers better consuming bills because the bill is based upon the packets. So when it comes to circuit switches service, the cost is determined by the length of the connection. Here, the length of the packet. So that is why the bill is made easy or simple. One of the significant disadvantages of circuit switching for IoT is cost effectiveness. The connection length determine the subscriber operation cost in the circuit switch, the connection length. So that is why it is a different disadvantage of circuit switching. But here it uses packet switching, so this demerit is overcome or avoided. Uh, a significant speed. So GPRS as compared to GSM provide a higher speed. GSM was designed to transmit data at approximately 14.4 kbps per second at first. Over 2G network, GPRS on the other hand provided data speed up to 86 kbps. So in 2G network, the data speed increases. So in GPRS, as compared to a GSM network, the speed is more. So another benefit of GPS that is always available. The GPS connection can provide constant internet connectivity, quick messaging, and improve SMS transfer. It is a faster network even when it is fast launched. So after GSM it was launched. So at that time it was the fastest network. With the standard global system of mobiles communication technology, somebody could transmit only 10 SMS per minute at that time. If you compare nowadays speed, it is very poor. 2.5G. Uh, Actually, there are some network in between 2G and 3G, 2.5G. That this network provide the data speed which are in between 2G and 3G. So enhancement that provides packet data capabilities over 2G network, 2.5G improve the available data rates supported by the air interface. The increased data rate rise to theoretical maximum 384 kbps in 2.5G. Although the field available data rates may often be as low as 20 kbps, general packet radio services GPRS is an example of 2.5G technology. So as you know that is the GPRS is nothing but it contains 2G and 3G mobile devices, but GPS system also known as a 2.5 technology, 2.5 GPS technology, 2.5G. So after 2.5G, the 3G mobile are there. The third generation mobile phones and 3G internet mobile phones is set of the standard for wireless mobile communication system that promises to deliver quality multimedia service along with the high speed, high quality voice transmission. Obviously, that is the Internet Mobile Telecom Standard. 3G system is compiled with the International Mobile Transmission. So there are some standards. There are some by ITU or IME, Internal Telecommunication Union. The first 3G service is available in 1998, almost 25, 27 years ago. It provides high-speed transmission having data transfer rate more than 0 to Mbps. Global roaming services are also available for both voice and data. It offers advanced multimedia access like playing music, viewing video, television services. In recall, your GSM system does not support this one. That is, there are no television services, viewing video. It provides accessing to all advanced internet services. For example, you can surf web pages with audio and video. So nowadays, after 3G, we all are using this. It used in this area of applications, and we are familiar with this wireless voice telephony. That is, voice telephony can be a fixed wireless internet access. We can access the internet. We can browsing internet, shopping the internet web pages. Video calls. So video calls now be possible, but in GSM mobile does not have these features. Mobile TV technologies, uh, video conference, video on demands, GPS system, global position system nowadays available, location based services. So now we are familiar with these terms and we are using this from uh, 3G network onwards. And then the 4G mobile, fourth generations, where it provides a broadband cellular network services and successor to 3G mobiles. It provides an all IP-based cellular communication internet protocol. The capability provided other to IMT advanced specification are led by the ITU, Internal Telecommunication Union. This also the standard which are opted by the 4G mobile. Obviously, it has some. It provides an all IP. It is also packet switches, not a circuit switcher network for transmission of voice, data, signal, and multimedia. You can send any voice data, audio data, or any signals. It aims to provide high quality uninterrupted services to any location at any time. So now it is visible.
Yes,
Yes,
yes.
sir.
It's visible.
Okay. Uh, uh, also here. So as you know, it contains all the IP packets, switches network uh, for transmission of voice, data, and signals, and multimedia. Not only voice or only data. It contains the multimedia files. It aims to provide high quality uninterrupted services to any location at any time. So 4G network should have peak data rates of 100 Mbps. It is fastest among all the network we have discussed so far. Uh, for highly mobile station like train, car. Suppose you are traveling from one in a mobile like your mobile station like a train or a car, and 1 Gbps for mobile station like your residence. That is, if you are in a fixed location, if you are staying in a residence, that is it, the speed up to the 1 Gbps. So it also lays down the 4G network should make it possible for 1 Gbps downlink over less than 67 megahertz bandwidth. They provide have smooth handoff across the heterogeneous network. That is, that is when we are traveling, we are not only change our network, the which where belongs. That is called the home network. Suppose you are traveling and you are entered to another network. This network may be homogeneous, may be heterogeneous. So there should not be any drop in your communication. You continue communication when you are traveling, and this is the features of a 4G network. Let another evolution, LTE. I think you all are aware of this and heard the word LTE, long-term evolution. It is an extension of 3G technology, and it is a standard for the high-speed mobile communication based upon GSM or Edge or UMTS SAP. These are some technology, mobile technology. And here the peak data rate of the download is 100 Mbps, and the upload is 50 Mbps. The LT advance meets the specification of some standard are there. And the peak data rates are 1000 Mbps, and the downlink and 500 Mbps for uplink. Then its application area. Sorry. Advanced mobile web access. IP technology. We'll discuss about IP technology after some few slides. We'll get the IP technology. What is IP technology? Internet protocol technology, and it use and its features are there. High resolution, high speed gaming services, streamed multimedia and data, stream mobile TV, and these are video conferencing and 3D television. These are the features of the application area of the LTE. Mobile computing architectures. This is important. Uh, the architecture represents the blueprint about the multiple layer in between network hardware components, devices, and user application interface. And it is a well established architecture required to getting the access data. And we have three tier architecture of mobile computing. One is a presentation layer, application layer, or data access layer. Uh, um, the three major layer are there in the architecture of the mobile computing. Each layer has different functions. They have they are there to perform the different functions, and the other name suggests presentation layer. It is closer to the user. The user is closures, and there are some application layer which is in between the data access layer and presentation layer, and the actual data is available in the data access layer DM, and your application layer is in between. You can tell it is a medium between your presentation layer and the data access layer. We first see presentation layer. This layer lets user to face device handling and rendering. The users are closer to this layer. As the name suggests, presentation layer, the user are closer to this layer. Application layer, it allows executing business logic and rules. There are some rules, there is regulation how the data is traveling from the data access layer to the presentation layer, and you can tell it is a medium between your UI, that is presentation layer, and your data access layer. And data access layer, it lets to get access and management. The data is actually present in this layer. You see the block diagram. The user access, you see the user interface UI, the tier 1, and your middle tier 2, it contains some business tax and process layer, but actual data is available in the data tier and tier 3. So you see there are some shielderic like structure which contain the actual data. So when a user wants to view show the data will be viewed in the presentation layer, which is closer to the user. That is called the user interface. You see there are some hexagon like structure in user interface. So it is a 3-tier architecture. So first discuss the presentation layer. This layer is closer, as we discussed, it is closer to user. It has a main responsibility to present the information to the user. So this is an important uh, layer. That is, if you don't present the data is there, the middle layer is there, but data is not present to the user, so it is meaningless. We are here from the user. So this layer is presented to the user. The data is presented here by the help of this layer. User are able to grab all information via speaker, vibration or screen. User can send the information with helping of the input, like any key, any input devices like any your keyboard, mouse, touch screen. And the layer is enabled with web browsers, customized client program, web browsers. So presentation layer allow accoupling via client side data such as dynamic HTML and data resource. So user give the input. Suppose you have to click one thing, one button to find the data. The data actually comes from the data, the last layer, third layer, and how it is comes, it is managed by the middle layer. Okay. The application layer, which is a medium between these two. So when a user gives a request, the request come to the data is retrieved from the data the last layer through the middle layer. And data access layer, which is the layer is implemented to keep stored data that is required by application and work as a repository to both temporary and permanent data. All the temporary and permanent data are just stored there here. Data cell layer is built up, some DBMS package are there. These offer data for above two layers. The layer is also known as DBMS access layer. You can also take DBMS access layer, but actual data is present here. All data is stored into many format like as a text file or relational database. So this is the architectures of. We'll discuss about more in the previous because my this is the last connection is not there. So the mobile IP we'll discuss in the next class.